Now let's have a look at the various properties or the important properties of arithmetic mean. I'm using AM, capital AM, to denote arithmetic mean. The first important property is that the algebraic sum of deviations from the arithmetic mean, deviations of each observation from the arithmetic mean, is equal to 0. To convince yourself, you can just take any random set of numbers. So say I'm taking the numbers 7, 8, 7 plus 8 is 15 plus 3, 18, and say I have taken these 4 numbers. I have randomly made up these numbers. So the arithmetic mean of these numbers would be 7, x1 plus x2 plus x3 plus x4 divided by n, the number of observations. So that's 4 over here. So that's 20 divided by 4. My arithmetic mean is 5. Now let us look at what is the sum of deviations. Deviations of an observation means the observation, how far is it from the calculated arithmetic mean, right? So the arithmetic mean is 5. So 7, I should write this in general terms. So x minus 5 will be the deviation, where x is each individual observation. So 7 minus 5 is 2, 8 minus 5 is 3, 3 minus 5 is minus 2, and 2 minus 5 is minus 3. Remember, the signs are very important. Okay. Now as you can see over here, summation of deviations is equal to 2 plus 3 minus 2 minus 3, which is equal to 0. This is just a random example that I made up. You can use any numbers that you choose. In fact, if you want, you can actually try this out on an Excel spreadsheet. Just to convince you, I have taken an Excel sheet and now I'm going to type in a few numbers. Okay, continue with the Excel example. I've just filled in the numbers and filled in the formulas, and I can just show you. Over here, what you see over here, the x variables are randomly. I have taken 9 values, x1, x2, x3 until x9, and over here in red, what you see is the sum of these 9 values divided by the count, that is 9. So this is the arithmetic mean, 347.7778. Now in the next column, I am calculating deviations using this formula. That is x, or the observation, minus its arithmetic mean. So for each cell, what I have done is, I have each cell over here, I have subtracted the observation, corresponding observation, minus the arithmetic mean, 347.778. So as you can see, in each of these cells, the formula gives observation minus the arithmetic mean. And over here, I have taken the sum of all these deviations from minus 291.78 to 1217.22. And as you can see, it is 0. So take an Excel sheet on your own and try any different values. You will always get a number, sum of the deviations equal to 0. Now the second property of arithmetic mean is that if we have two different groups, group 1 has n1 observations and it has an arithmetic mean which I am denoting as AM1, and I have another group of observations regarding the same variable where the second group has n2 observations whose arithmetic mean is AM2. In this situation, I can always find the combined arithmetic mean of the two groups. The formula for doing that would be the combined arithmetic mean x bar will be n1. Okay, let me denote it by x1 bar and this by x2 bar. So it will be n1 times x1 bar plus n2 times x2 bar divided by total number of observations, which is n1 plus n2. So this is one of the desirable properties of a measure of central tendency that we discussed earlier, that if we have two different sets of data or groups with the same data, it is possible to combine the two groups and find a common measure of central tendency. Right? Now this can also be generalized if you have more than one groups. Your mean of the combined population would be n1 x1 bar plus n2 x2 bar and so on. Say we have k groups, nk x k bar, and in the denominator you will have n1 plus n2 etc. till nk. Right? So this formula is quite helpful. All those who are interested in going for any sort of competitive examination, do remember this relation. It comes in very handy and useful. We can have problems based on this property. I'm taking the example from the book where you have two classes. Class A, which has 40 students, and the average marks of these students is 38. Similarly, you have another class, class B, which has a strength of 60 students and their average mark is 42. If you are combining this class, you might want to know the combined average of the combined class, and to do that you will use the formula that we discussed above. So you will use 40 into x1 bar plus 60 into x2 bar divided by the total number of students, that is 40 plus 60. So remember, you have to always use the BODMAS rule. A few students who are a little weak in maths, you should remember that the BODMAS rule says that multiplication will always come before addition, right? So what that means is, first I'll solve 40 into 38, then I will solve 60 into 42, and then I will take the addition of these two terms. Okay, if you're using a scientific calculator, it becomes very simple, but for others, if you are using the normal calculator, please be careful that the order of operation is multiplications should be solved first and then the addition. Okay, so the answer in this case would be 40 into 38 60 into 42 is 2520 divided by 100, which is 4040 divided by 100, which is 40.4. So if you have a combined class, the average of this combined class will be 40.4. Okay, in the assignment I'll give you more such problems, and once again remember, this relation comes in very handy when you are solving data or mathematical questions in competitive exams. The third very important property of the arithmetic mean is that the sum of squares of deviation from any measure of central tendency will be minimum if the measure of central tendency chosen is the arithmetic mean. So, when you're selecting deviations from arithmetic mean, the sum of the squares of the deviations will be minimum. In terms of symbols, what that means is deviation is defined as the observation minus, I'm calling A the arithmetic mean. So this is the deviation. Sum of squares would mean you square these deviation and you sum it up across all your n observations. Now, if this A is arithmetic mean, technically you can use any number and select any value and select calculate deviations from that value. But if this particular number A is your arithmetic mean, then the sum of squared deviations will be minimum. This is a very important property of the arithmetic mean. Based on this property, we have what is called the ordinary least squares method, which is used, or criterion, which is used for regression analysis. We will deal with this in more detail in your last module, but just remember that this property of the arithmetic mean is very important, and it is termed, based on this we have the ordinary least squares criterion. It is also known as, the short form is OLS criterion, ordinary least squares criterion. Okay.